Hello, so for part 2 of this challenge, we did a continuation of the fishing game. So as you can see, between challenge 1 and challenge 2, we used ImGUI, which Michael provided in the labs and tutorials for his framework to kind of toggle between different lighting effects and shaders. So right now you're looking at diffuse, which was in the previous one. So I can go over to ambient now, and then specular lighting. And what we added new into this is our bright pass is now working, as well as the blurred bright pass, and finally the bloom effect. So if I go back here, something else that we added is you can now move the line itself as well as the hook up and down, as we've created separate objects for these. And if I go down enough, you'll see I'll have to wait for the fish to come back, but so its color will actually change when it is in the vicinity of the hook, as well as turn back. And I can move it up and down with maximum position being right here. So to get into the code itself, I'll just simply all our includes up here. The framework is by Michael, the TA for this course, of course. And we just have, let me see. So to start off, we declare our 3 frame buffers. So we need one for the scene, one for the bright pass, and one for the blurred bright pass. We didn't initialize them in a function here to keep it separate from all the other code for better organization. And if we had more frame buffers, we could simply add them into this function, as well as declare them here for maybe more of a blur effect or whatever other post-processing we need. We added a couple more shaders, so the blur, the bright pass, and the composites as well. So if I go down here, we just link the bright pass, the blur, and the bloom. So bloom being the composite fragment shader. I already showed this in the last challenge, but just loading all our meshes from OBJ files. We don't really have any textures on them, so they aren't loaded. We initialize the scene with obviously our fisherman, fish, shark, dock, line, hook, etc. We have simple movement for the shark and fish to move back and forth, as well as the fisherman and line being able to be manipulated, so the fisherman can move left and right using this variable, and the line can move up and down using our L position variable, which is altered in the keyboard callback function, which you'll see later. Our set material for all game objects function, which Michael provided from his framework. So our bright pass function here simply binds the bright pass frame buffer and clears it, and then binds the scene FBO for texture sampling. We then bind the bright material to the shader itself, and we apply the bloom threshold and all that before drawing a full screen quad to show the post-processing itself. And then at the end of this function call, we simply unbind the texture for the scene frame buffer object. And it's the exact same thing for the blurred bright pass function. We also have our simple collision here, so 2D collision we're using for this. And for our display callback function, this is where we set up and bind the scene frame buffer object. So we bind it and then quickly clear it right here before drawing the scene through the player's camera perspective. And then after drawing the scene, we unbind it. And this is important because if I scroll down here to our bloom effect itself, so it calls these 2 functions that I showed earlier before binding the scene frame buffer again for texture sampling, as well as the blurred bright pass frame buffer object as well. We then unbind the frame buffer and clear the frame buffer window before applying the bloom texture and then drawing the full screen quad to show off the post-processing effects. And then we unbind the texture for the scene FBO, as well as the blurred bright pass FBO. And what you see here is the framework Michael provided for the mGUI kind of menu box there. So we have our default shading, which is diffuse, ambient, specular, bright pass.
Hello and welcome. My name is Bosco, and I'll be talking about what me and my partner were able to implement on top of Challenge 1 in Challenge 2. So first of all, we have bright pass, and as you can see, how we able to get that effect is in main here. You just declare a bright pass variable, and then take a text. It will take a texture, and then inside there's the scene, and the texture coordinate, and then how you get the final result is by using this formula right here called clam bright pass minus bloom threshold, and then divide it by 1 minus the bloom threshold, and then set it to 0 and 1, and then there you have it. And then next we have the blur effect, and obviously we make a function, and then we declare the UV with the texture coordinate, and then in X and Y direction, and then we declare offset coordinates with 9 elements, and here are the 9 elements, as you can see, and then we declare a variable named blurred, and then set the intensity kind of thing, and then we need to apply those to all the pixels with these calculations right here, and then obviously return the result. And then in main we need to declare same thing, blurred, and then call the function, and obviously it will does a drop, and then apply it back to the output color or the output calculation. And then we have bloom effect, which lights up the scene. And how we can do it is in main, in the shader in main, we declare a variable called scene, and it takes a texture and with the scene and texture coordinates, and then also the bright pass. Also, it takes a texture, and then with like the bright pass function, and then the texture coordinate, and then you just add them together to get the final result. And then so we also have toon shading added to give the game like a retro feel. And how we did it was obviously make a function, and within it we normalize have 2 variables normalized, the light position XYZ minus the viewer position, and then also normalize the normal, and then end.l standard stuff, as in the diffuse shader. But what we do here, we actually check the value of the diffuse color, and do another calculation in order to do that toon shading. And then obviously add that back to the output formula to get the result we want. And this is the toon shading, as you can see on the left.